This conference will now be recorded.
Okay, today we are going to see how we can find derivative and integral of functions. We can consider a single variable function and multivariable function, and similarly different integrals, double integral, single integral, like that. Anyway, we can start with derivative. Here we are using a package SymPy. SymPy is the package we are using. If you are using this Anaconda distribution, it will be automatically that SymPy package. Otherwise, I don't know exactly regarding other platform. Anyway, here in this platform, in this I am using that Anaconda prompt. For that SymPy is there. Initially, I am importing this SymPy for doing this differentiate, that is finding derivative of a function. Therefore, import SymPy as SYM or SP, anything we can use in Python. Sorry, SYMPY, SY it is actually. Import SYMPY as SYM. All of you, please import that SymPy package initially. Here I have imported this SymPy. Then we are initially find the derivative. Then I will say what is meant by that SymPy package. What is the significance of that SymPy? Here I am going to find the derivative of a function x raised to 5. That is two parts there. That is in the integral and derivative. That here analytical and numerical. This analytical derivative we are actually finding x raised to 5 is the function. It is differentiating with respect to x. For we know its differential, that derivative is 5x raised to 4. We are using this SymPy package and it is imported as sim. Then next is x equal to SYM dot symbol. Note that here that S is capital letter. X equal to SYM dot symbol in bracket X in single quotes SYM dot DAFF. Then in bracket I am giving that function x raised to 5. Therefore x raised to 5 can be given like this. It is displaying the answer 5x raised to 4. This we are using that SymPy package for finding the derivative of a function here. Here we are differentiating with respect to x for that symbol, and here in that symbol that s must be capital. It is in the first step we have imported that SymPy package. Import SymPy as SYM. If you are giving import SymPy as SP, then no issues. X equal to SP dot symbol in bracket X and SP dot DAFF. here it is that function which is finding that determining the derivative of the function. For here we are finding the derivative of the function x raised to 5. We know the answer is 5x raised to 4. Okay, only that much line of code for finding the derivative of a function. Okay, hope that you have got this. We can find the derivative of a function. Here a function we have taken as f of x is equal to x raised to 5 and its derivative is determined as 5x raised to 4. Okay, next we can consider another function that is a product of two function, that is we can consider f of x into g of x, that form. A function is of the form f of x into g of x, then we know that the first derivative of this function is f of x into derivative of the second function. Therefore f of x into g dash x plus g of x into f dash x. It is that product rule. It is two functions multiplied, f of x into g of x, then we know the derivative of the function is f of x into g dash x plus g of x into f dash x. Okay, we can take the function as x square plus 1. You please note the function as in bracket x square plus 1, x square plus 1, x square plus 1, that is the first function. You please note in a paper x square plus 1, that is the first function. Then second function is cos x. For our function is f of x is f of x equal to x square plus 1, then cos x. Put that x square plus 1 in bracket. Therefore we can find the derivative of this function as first function x square plus 1 into derivative of the second function, therefore minus sin x plus cos x, that second function, into derivative of the first function 2x. For we get 2x cos x minus x square plus 1 into sin x. Okay, isn't it? That is, I am giving you a function x square plus 1 in bracket into cos x, x square plus 1 into cos x. We will have to find the derivative of this function. Okay, if you find the derivative of this function manually, what you will get, please say someone, or otherwise type in the chat box. What is the answer? What is the derivative of the function x square plus 1 into cos x? I'm audible, isn't it? All of you please say yes or no in the chat box. I'm audible. Please, some more responses. Okay. Okay, anyway, we can find the derivative of the function x square plus 1 into cos x. This here, for that, we have already imported the package simpy, and that x equal to sim dot symbol in bracket x. Then next we will have to give only that function whose derivative is to be find. Therefore sim sim dot diff diff sim dot diff in bracket x square plus 1. For that we will have to give it like this, x square, so that symbol, asterisk symbol, twice into 2 plus 1, close the bracket, plus sim dot cos x. Sorry, it is here, it have to be taken. I don't know how some was stacked we'll type once again sin sim dot diff x square plus 1 into cos x. Please wait. Okay, now it is okay. Sorry for the disturbance. I think you have got it. That is sim dot diff, then in bracket x square plus 1 into sim dot cos x. We will have to give like that, into sim dot cos x. That is, we have imported that sim pi as sim. Therefore, this way giving like that sim dot cos x. I think you have got now this sim dot differential DAFF in bracket the our function x square plus 1 into, again we will have to give that sim dot cos x, then only we will get the answer. That is, here if it is in the form of this product of two function, then we get the answer as 2x cos x. It is the answer here, 2x cos x minus x square plus 1 into sin x. 2x cos x minus x square plus 1 into sin x. That is derivative of the first function and the first function into derivative of the second function plus second function into derivative of the first function. That is the formula we are using. Anyway, we have got the answer. Next is we can consider another. That is, it is of the form our function whose derivative is to be find function f of g of x, f of g of x. Then we do the derivative like this. Hello. Okay, our function is f of g of x. Then we find the way like this, f dash of g of x into g dash of x. That is, for example, you take this example, x square, I will type here x square minus 3x, x square minus 3x. I am typing in the chat box. I will give you plus 5, put it in a bracket, raised to 3. That is x square minus 3x plus 5. You can see now in the chat box. Our function whose derivative is to be find x square minus 3x plus 5 all raised to 3. The function we will have to find the derivative. What is the method we do? That is, we have the function of the form f of g of x here, f of g of x. Then we find f dash of g of x into g dash of x. That is, first we take that function together. Therefore, 3 into x square minus 3x plus 5 raised to 2 into derivative of this function, that is 2x minus 3x, isn't it? That is, here function whose derivative is to find out is x square minus 3x plus 5 all raised to 3. Then the answer is 3 into the function x square minus 3x plus 5, then derivative of this function. Therefore, 3 into x square minus 3x plus 5 into 2x minus 3. That is our answer. Then multiplying, we can get the simplified answer. Then we can find the derivative here. sim dot daf, then in bracket x square minus 3x plus 5 raised to 3 raised to 3. That is a function. Some syntax. For 3x, 3 into x, we will have to give like that. It is 3x. I have typed the 3x. 3x. Okay, so we have got the answer. Okay, I think you have got the answer. Okay, I think you have got this. Next, we can go through a derivative of multivariable function, which we called as partial derivatives.
This conference will now be recorded.
Those who have not got the answer, please note what I am seeing. Then later you can try. Next is we will have to find the derivative of f of xy. F of x comma y is equal to x square y. That is the function. That is f of x comma y equal to x square y. I have given the function in the chat box. F of x comma y, a multivariable function, is equal to x square y. Then the partial derivative. If we differentiate with respect to x, we will treat the other as a constant. Therefore, the partial derivative with respect to x, we get 2xy, and if you differentiate with the y, we get, that is dou y of this function, dou y of f of x square y equal to x square. That is the answer. We can excuse me, anyone said, anyone? Has anyone said anything? Okay, here we will have, earlier we have initially for a single value function we have given it as x equal to sim dot symbol, then in bracket that x. Here we give like this, x comma y, only that is the difference, x comma y equal to sym, sim dot symbols. Here we are, that s is the small letter, symbols, x comma y equal to sim dot symbols, then in bracket in single quotes x space y, close the single quote, then close the bracket. This for a multivariable function, that is here we have x and y, then we are finding that partial derivative. For we will have to give like this, x comma y sim dot symbols in bracket x y, then give our function. Here we can consider the x square y, that function as x square y. Therefore give that function f equal to x square into y. f equal to x square y. Then for finding the derivative, sym dot diff in bracket f comma x. This f is our function which is in that two variables x and y. Then here we are finding that dou x, that partial derivative with respect to x. So we get that answer 2xy. Then similarly we can find the derivative dou y with respect to y. Only we will have to change that x. This sim dot diff in bracket f comma y. We get the answer x square. Here you will have to note this, that is x comma y equal to sim dot symbols. Here that symbols, that is the function actually making use of from that symby package. Symbols here, the s is small letter, whereas if it is a only single valued function, single variable function, then here x equal to sim dot symbol, here that s is capital. If it is small, it will does not work. You can check this. Okay, anyway here sim dot if with respect to y we have found the answer. Similarly we can find the multivariable function partial derivative with respect to three variables. For example, we can take the function f of x comma y comma z. I am typing in the chat box. F of x comma y comma z equal to, we have a function x square y z raised to 5. Z raised to 5. It is the function x square y z raised to 5. Then here if you find the differential with respect to x, that is dou x of f of x y z, that is our function dou x of f of our function x square y z raised to 5. We will get, that is we will keep the other variables y and z as constant. Therefore we get 2x, that is a differential of that x square, 2x y z raised to 5. That is the answer. Similarly dou y of this function is x square z raised to 5. Then dou z, partial derivative with respect to z, we get 5 into x square y z raised to 4. We can check. Here we will have to give, that is x comma y comma z equal to sim dot symbols. Here all are small letters. Sim dot symbols. Then in bracket x space y space z, that single quote, then close the bracket. That is we are using multivariable function, that is here partial derivative with respect to three variables, and the variables are x y and z, and give our function whose partial derivatives is to be find out. Here x square f equal to x square y into y, therefore into y into z raised to, for z raised to 5. That is our function. Then sim dot diff with respect to y, x we can initially find. For sim dot diff in bracket f comma x, we have got the answer 2x y z raised to 5. That is got the 2x y z raised to 5. Then with respect to y, we know the answer is x square y z raised to 5. X square z raised to 5. X square z raised to 5. we have got the answer x square into z raised to 5. That is the answer. Similarly, with respect to z raised to it is 5x square y z raised to 4. That is the answer. Okay, it's about that partial derivatives. Then before going to other, I will say something. It is we can save these. Those who are using this command line, any of the command prompt, we can save these codes. We are entering the code by as a single line. We can save all this. That is, we can see the history by simply typing. That is what we have typed so far. For that, percentage type like this, percentage history, that percentage symbol and history. You can see these are the things I have typed now. After starting this particular session, it is by taking this command prompt, I have typed all these codes, all these lines of code. It is simply typing percentage history. Then we can okay, we can start. We can continue. That is in between. I have received a call. Sorry. That is by typing that percentage history, we can get all the things I have typed in this command line. Then one more thing, if you type like this, that is percentage history then hyphen n. A space is required there. That is, then we can see the line number. This first I have typed that import sim by as sim, like that. All the thing with a line number. Then we can save this particular thing. That is, by making use of this particular history command, we can see retrieve. Then we can take part of this particular things, those we have typed. That is like this. That is percentage history. Then line numbers. We like to type. See the line numbers from 3 to 10. Then type like this: percentage history 3 space 10. Sorry, here it will show line numbers 3 and 10. Then if it is typing like this 3 hyphen 10, sorry, it is percentage history space 3 hyphen 10. Then all the commands typed in between that 3 and 10 will be displayed. Okay, that is, you can make use of this for saving these, and we can save as a Python file which can be executed. That is a complete a script file as like this. For that we can type like this: percentage save. You please note these things: percentage save, then a file name, for example xyz, typing dot py, xyz dot py. Then the line numbers which we are in need of this. If I am in need of from 1 to 25, 1 hyphen 25, it will be saved as a file. It is percentage save, then a file name dot py. If you are, I am taking only 1 to 10. That is, it is showing that file name already exists. Override, yes. That is, I have saved that particular lines from 1 to 10 as a file xyz.py, like that. Okay, you can save files like this as a complete, which are typed in this command line. That is add-on things you can take for saving, or those commands which we have typed. Only that much. Okay, next move on to our, we can concentrate on this derivatives and integral, and using this SymPy package. That is, here we have used this SymPy package for finding the differential. Actually, this symbolic computation, it is the, it means a symbolic computation. It deals with the computation of mathematical objects symbolically. It is by using this SymPy package, it is doing the computation of mathematical objects, we can say symbolically. It means that mathematical objects are represented exactly, not approximately. This initially we are representing the mathematical objects exactly, and the mathematical expression with the unevaluated variables in the symbolic form. That is, I will give you an example. That is, you can take this. That is, import math package is imported, and I am finding the square root of a number, math dot sqrt, that give the square root of the number, square root of 9. it gives 3. Then I am finding the square root of 8. I have got the value 2.82 something. Can you say it is the correct value, exact square root of 8? This I have found that square root of 8 here. The answer given as 2.8284 something 1903 etc. Can someone say it is the exact square root of 8? You take a calculator, then in your mobile or anything, calculate square root of 8. Please someone say, but is it is the exact value of square root of 8? No answer. Please say someone. It is the exact value. Correct value ആണോ ഇത്? നിങ്ങൾ കാൽക്കുലേറ്റർ എടുത്ത് ചെയ്താൽ പോലും ഇതിൽ കൂടുതൽ കിട്ടും. ഇപ്പം മൊബൈലിലെ കാൽക്കുലേറ്റർ എടുത്തു കഴിഞ്ഞാലൊക്കെ ഇതിൽ കൂടുതൽ വാല്യൂസ് കിട്ടും. Okay, anyway, it is not the actual square root of 8. We can say we cannot represent it by a finite decimal, this square root of 8, since it is an irrational number, isn't it? It is an irrational number, therefore we cannot represent it by a finite decimal. We can represent this root 8 in another way. That is, we know root 8 is equal to square root of 4 into 2, therefore 2 root 2. 2 root 2 we can represent like that, that root 8 can be represented as 2 root 2. This is where the symbolic computation comes in. Okay, here we have already imported the SymPy package. Then we can try this with this SymPy. SymPy. Okay, as we have sim have imported this as sim. For sim dot sqrt of 9 I am giving here. It is giving 3. Then I am giving sim dot sqrt. Sim dot we are actually using that SymPy package. We have imported that SymPy package as sim already. We have imported that SymPy package as sim. Therefore we can try sim dot sqrt of 8. It is showing 2 into sqrt of 2. Okay, it means 2 root 2. That is the difference. That is, while we are using that SymPy package, that is some symbolic computation. I think you have got the idea. That is, when by this while we are making use of this SymPy package, initially that square root of 8, it shown a value. We know it is not the exact value, and we are not able to, we cannot represent this by a finite decimal. It is not a finite decimal. Therefore, it is since it is an irrational number, therefore we can make use of this symbolic computation. That is why while we are using this SymPy package, this square root of 8 is displayed as 2 into square root of 2. That is that our 2 root 2. Okay, then we can again see have already imported that symbols x comma y equal to symbols, and in bracket x y symbols. Okay, we have not separately imported that. Okay, we can do initially that. It is from that SymPy we can import from SymPy import symbols, import symbols. Then xy symbols xy. Then I am giving an expression expr equal to x plus 2y, 2 into y, x plus 2y, expr equal to x plus 2y. Then that expr we will get x plus 2y. Okay, then I am doing expr plus 1, then it will give x plus 2y plus 1. Then expr minus x, that give 2y. You can see what we are getting that as output. It is that expr is a function in two variables x and y. Then by giving some modification, that results we have obtained expr minus x, we get that 2y like that. Then can find x into expr, x into expr, that gives x into x plus 2y. Then we can make use of some functions in the SymPy. That is it is in an expanded form. That is we can see x into x plus 2y, we can write as x square plus 2xy, x square plus 2xy. For that we can import from SymPy. From SymPy import expand and also factor. Once it is expanded, then we can also represent it as a factor in a factorized form. That is here x into x plus 2y. Then I am giving the name like this, expanded vector. Okay, expanded expr is equal to, we are using that function expand, then the function x into expr. That is, we have already the function expr equal to x plus 2y. We are multiplying it with x. Then if we use this expand function, which is part of that SymPy package, we can see what is the output. Expand it, expand it, x into Okay, it is the code is executed, then we can see what is that expanded expression. That is x square plus 2xy. It is uh, multiply that x into x plus 2y. It is multiplied there, therefore x square plus 2xy. Then we can once again we can make it as a factor of this function. It is factor. We have already imported that function factor here from the SymPy for factor of expanded expr, factors of that expand. That is again it is returned to that factored form x into x plus 2y. Then we can also do some um, techniques in order to get a that print in a better way. That is to make pretty print with Unicode characters. That is here it is seen that QRT of 2, that we can we get it as 2 into root 2, like that, in that way. For that mm, thing can try it init underscore printing it, printing, then in bracket use underscore Unicode equal to true. Different Unicode. Okay, wait. From SymPy import star. I think now it is okay. Okay, you initially run this code from SymPy import this star, then init printing use Unicode equal to 3. Now we can try that. Okay, sim dot square root of 8. Okay, it is displaying as 2 root 2. It is some anyway that in place of that sqrt, it is showing the square root symbol here. I will try by making this false. No. Then once again okay, with that we can see 2 into root 2. It is actually that into its corresponding Unicode, it is not working properly. Anyway, here with this we can see 2 into root 2 in place of that sqrt, it is showing that square root symbol. You can see That of 3, what it is showing for 38. It is root 3, like that. Earlier it was displaying as sqrt3 by using this SymBay package, but we are making use of that Unicode character, corresponding Unicode character. That is why we have got this square root symbol. Okay, we can make use of all of these. Okay, that's about that initial part here. Then we can move to integral. Okay, I think you are following. Please someone respond in the chat box, yes or no. You are following. Have already discussed the derivative of the function. Now we are moving to integral of a function. Please say yes or no. Okay. Okay, I will explain different codes that we can make use of this. Then finally we can do the complete code that is in your syllabus. That please wait, I will take that particular one. I think that fourth and fifth experiment combinedly. Okay, is numerical. That fourth experiment 4 is numerical differentiation and integration. I will share that. Okay, here it is, the syllabus here. That is, hope that you have gone through this numerical differentiation and integration. That is that fourth experiment. That is, realize the functions, then compute the first and second derivative this function using built-in tools such as grade. Here we are making use of another. Anyway, plot the derivatives. We have studied that plotting. Familiarize the numerical integration tools, the language you use. Realize the function and plot. Then use the general integration tool to compute integral -2 to 2 f of t dt. Then repeat the above steps with the trapezoidal and Simpson method and compare the result. We will all see these Simpson method and trapezoidal method. Find the anyway. Go through the syllabus. I will explaining all the terms that functions we are making use of in order to solve this. Okay, we can move to that IPython itself. Okay, in between I will say one more thing. You can use an site here. Okay, I think I will say I will give that wolf WOLF RAM alpha ALPHA wolfram alpha a site where you can make use of this, or I will share this. it is. I think you can see it is enter the what you want to calculate, that is differentiate. And integration. Okay, I will integrate. Okay, I will take this example. It is you can find the solution to the integration and differentiation in this from this particular side. You can check for the correctness of the your answer. If you are giving the complicated functions, no need of doing it manually. You can make use of this. X square sine cube x dx, then its solution, then its plot, all will be given. Anyway, you can check this particular site, Wolfram alpha. Integration, differentiation, anything can be done. It's a you can make use of this free version for this particular purpose. Its pro version, paid version is also there. We are not in need of that. Okay, next we can do the integration. Okay, initially we can find the analytical integration of the function 3x square plus 1, integral 3x square plus 1 dx, and then it's numerical. Okay, 3x square plus 1, that is our function. uh, to for which we will have to find the integral. Okay, here give x equal to sim. We have already imported the simpy package as sim. We can make another numerals, import simpy as sp. Then we will have to type here x equal to sp dot, here x equal to sim dot symbol, s capital here, considering only one variable here, sim dot symbol, then in bracket x. Sim dot symbol bracket x, sim dot symbol x, then sim dot integrate. Okay, sim dot integrate, sim dot integrate. We have the function 3x square plus 1 for in bracket 3x, 3 into x, you like to give like that square, then 2 star 2 3x square plus 1 comma x, here with that dx, that have got x cube plus x. You know the integral of that 3x square plus 1 is x cube plus x. If you find the differential of this, x cube plus 1, we get 3x square plus 1. Okay, 3x square plus 1. Therefore, only x is here. Therefore, sim dot symbol s capital here, symbol in bracket x, then sim dot integrate 3x square plus 1, that is our function, comma x, that give the uh, answer, that analytical solution to this particular function, integral of this function. Okay, in that way we can find the integral of any of the function using this simpy package, sim dot integrate, that simply give the integral of the function. Okay, then we will like to find the numerical values, that is with that limit integral 0 to 2 3x square plus 1 dx, like that. 0 to 2, integral 0 to 2 3x square plus 1. Here we have find the analytical solution to this integral 3x square plus 1. Here we have got it as x cube plus x, then here 0 to 2, integral 0 to 2 3x square plus 1 dx. We like to find that that is numerical solution. For that we make use of another package. Here we are making use of simby package for this, for getting this analytical solution. That is next we use another package, skypy. That is the package we are making use for integration and for finding its numerical solution. That is, a sub package provides several integration techniques, including an ordinary differential equation, integrator, etc. And here there are different functions. For example, quad, general purpose integration, quad, QUAD, that is the general purpose integration. We make use of this function, QUAD. Then for double integration, we use DBL quad, double integration. We can do triple integration using the function TPL quad. All are part of this skypy dot integrate. It's part skypy dot integrate is a sub package of this skypy. And also we have other methods for integrating functions given from fixed samples, that is trapez trapz. You will see these this trapz and Simpson trapz. That is, use trapezoidal rule to compute integral from sample. You can see that in the next class. That first part we can do today itself. And next is SIMS, SIMPS. SIMS. Use Simpson's rules to compute integral from samples. All of you go through this trapezoidal rule and Simpson rule for calculating that integral to the next class. Okay, next. Initially we can see that quad, DBL quad, TPL quad, etc. Now that is here quad is a function provided to integrate a function of one variable. Okay, provide integration of a integral of a function of one variable between 2 points. For example, integral 0 to 1 ax square plus b dx. Integral 0 to 1, you can note this function, integral 0 to 1 ax square, small letter ax square plus b bracket a square ax square ax square plus b in bracket, then dx. We like to find its numerical solution. For that, we can do this initially from SciPy, and here normally it will be not part of your, this SciPy is not part of your distribution. You can do this pip install SciPy, pip install. It will take 1 or 2 minutes for installing pip install SciPy. If it is in Anaconda distribution, I think there will be no directly this SciPy. I have no exact idea. Anyway, I am using this for some days. Therefore, this I have already done. Okay. Or otherwise, you can initially try this code from SciPy, dot integrate, dot integrate import quad, from SciPy dot integrate import squad. If it is okay, I have, for me it is working. If it is showing that it is not installed the SciPy, then do this pip install SciPy. If you are using that collab or like this online version, I think there will be no issues. I don't know exactly. Anyway, how many of you have worked this particular line of code from SciPy dot integrate import quad? Please say yes. How many of you have? It is working, this particular line of code from SciPy dot integrate import quad. Anyone? It is working. Or not? It is working. Okay, fine. Okay. Otherwise, you will have you. Can anyone say? Joel Abi, can you say? Have you install doing this pip install or not?
Hello,
Joel Abi, which
hello,
platform you are using?
sir. Anaconda. Distributor.
Which which tool you are using?
Hello, Anaconda distributor. Spider.
ആ ഓക്കെ. അപ്പൊ ഈ സ്കൈപ്പ് അതിൽ അതും തന്നെ കിട്ടിയായിരുന്നോ?
കിട്ടിയായിരുന്നു.
Okay, then okay, it is fine. Otherwise, you do that command pip install SciPy. Okay, we can try that particular function integral 0 to 1 ax square plus b dx. Then I am defining a function here, def integrand, or any name you can give. Integrand, then in bracket x comma a comma b, this it will accept the function values of x, a, b, etc. Then colon here, then we will have to give that a return, return space. Our function is ax square, for a into x square, ax square ax square plus b, that is it will have to be returned. Enter twice, then that will return to that command line. Then I am giving a is equal to 2. Therefore that is a equal to 2 and b equal to 1, the function will be 2x square plus 1. That is the value we are finding, integral 0 to 1, 2x square plus 1. Okay, anyway, a equal to 2 I have given, then b equal to 1 given, then you will have to give like this, that answer integral value I is equal to quad quad. We have already imported that function quad, then in bracket integrand, that function name that given the define, we have defined a function there, ente, same, let us use inte grand, comma, that limit of 0 comma 1, then you'll have to let's see, give like this arguments args equal to, in bracket, a comma b, close the bracket, then again one more bracket, then we can find the value of that I. Okay, here we have got the numerical solution to that integral. You can check this, that is I equal to quad of integrand 0 comma 1 args equal to a comma b. In that way, that is here it is the solution, and this that error function, the second value, it is 1.6667, then 1.85, etc. e raised to minus 14, that is that error function, error value. Okay, anyway, that is the solution of this integral, that is integral 0 to 1 2x square plus 1, its solution, that numerical solution we have found out here. I think with that we can stop today.